Oh, hi there. Thanks for dropping by. My name is Chris Betcher. One of the fascinating and fast-growing areas of computing at the moment is artificial intelligence, or AI. Artificial intelligence is powering all sorts of innovation. You're seeing it showing up in all sorts of products at the moment, trying to make them smarter and faster and easier to use. There's one particular branch of artificial intelligence known as machine learning. And in this video, what I'd like to do is to introduce you to some of the important concepts behind machine learning, help you understand a little bit about what it is, kind of how it works, and just generally to have a better understanding about what machine learning brings to artificial intelligence and how that's affecting us all. So come on, let's go and explore.
Okay, well, let's get started with this game called Quick Draw. And this is a Google artificial intelligence experiment, but it's a great way to start understanding how machine learning really works. So you can find it here at quickdraw.withgoogle.com. And once you get there, we'll click on this Let's Draw button. And let's see what happens. So it wants me to draw an ice cream in under 20 seconds. All right, let's see. So we say, got it. All right, so I have 20 seconds starting now. An ice cream, I think, it would probably have
icy line,
that.
or string bean, or diamond,
and you can see it's
or
trying
star,
to guess down the
icy
bottom
triangle.
here what it is that I've drawn. And as soon as I draw something else
Oh,
here,
I know, it's ice cream.
look at that, it found out it was an ice cream. Now it wants a helmet. Let's just quickly go through this. A helmet, I don't know, how's a helmet?
Icy rainbow,
that.
or bridge. Oh, I know, it's helmet.
Yeah, okay. A penguin in 20 seconds. A penguin, I don't know what a penguin looks like. I don't know. It looks
Icy
like
line,
this.
or neat, or street light, or ear. Oh, I know, it's penguin.
Wow, okay. Even I didn't know that was a penguin. This is an ambulance. Let's do an
Icy line,
ambulance.
or bench, or garden hose, or vent.
wheel.
Icy submarine.
My drawing's
Icy
not
police
great,
car.
but let's put a thing on the top there.
Oh, I know, it's ambulance.
An ambulance, okay. We got number 5 here, a cactus. So I don't know how a cactus
Icy
looks.
street light, or line, or finger. Oh, I know, it's cactus.
Okay, fair enough. And finally, a tiger. Tiger. I don't know.
Icy circle, or moon, or blueberry, or bear. Icy pig, or dog, or pond, or compass. Oh, I know, it's tiger.
As soon as I put the stripes on it, realised it was a tiger. Now, here's the thing about this. It's a bit of a game. It asks you to draw 6 drawings, and you can have a go. This is great fun. Your kids will love this game. What's really interesting, though, is once you draw your drawings, if I was to go to, say, let's do ice cream. It's a nice, easy one. If I click on ice cream, it'll actually say to me that the correct match was this one, but it also looked a bit like a nail or a parachute. And I can see how it might think it was a parachute. But interestingly, if I scroll down the page here, you'll actually see that these are everyone else's drawings of ice creams. And what becomes obvious as we start to look at the drawings of ice creams is that there's something in common with all these drawings. And if your drawing includes some of these common items, then the machine will very quickly figure out that what it thinks you're trying to draw is an ice cream, or it's probably an ice cream. Let's just take a look at some of the others. Let's go back here. Let's look at helmet, for example, like that one. A helmet or an ear or a steak. And if you go down here, you can see, wow, there's a whole bunch of different ideas there about what a helmet might look like. But if you look at enough of them, you start to realize there's some commonality. And so this game then becomes kind of interesting in that, what is it about tigers that makes it a tiger? Well, stripes is one thing. Eyes and ears, whiskers, that's another thing. So what we're really doing here, just so you know, is we're really teaching the machine by lots of examples what objects look like. Now, if I go back to the front page here, you'll notice there's a link on the front page that says, we'll teach it by adding your drawings to the world's largest doodling dataset. If I click on that link, it'll take me into this, which is 50 million drawings of different objects. And if you look at some of these objects, you as a human being know very well what some of these things are. And it's hard to do this because if I hover over it, it will actually tell me. So it's a bit of a giveaway. Like there's a circle, there's a church, there's a chandelier, and so on. But if I was to not point to those objects and reveal the name, you could, as a human being, look at most of those things and figure out what they are. And it's interesting because like this one over here, for example, I don't know what this one here is, but I'm guessing it's a cookie. Yes, it is. It's a cookie. How do I know that? It's just a circle with some blotches on it. If I click on the cookie, it then takes me into the database and shows me everybody else's drawing of a cookie. And you can see that once you start to look at the drawings in bulk like this, it becomes really obvious what quality or cookiness, if you like, makes a drawing of a cookie recognizable as a cookie. And if I click this randomize button up the top here, it'll just pick another object. So here, for example, this is drawings of obviously cars. If I click it again, this is obviously drawings of teddy bears. Okay, now how do I know that? Right? Because teddy bears have a certain teddy bearness about them all. What we've done here is we've taught the machine what an object looks like by giving it lots and lots and lots of examples of what that object should look like. And then the machine can take those thousands of examples and start to draw conclusions. That's machine learning. Well, now how do we take this idea and make it actually useful? Well, here's an example. This is another Google artificial intelligence experiment. This one's called AutoDraw. Last one was called Quick Draw. This one's called AutoDraw. And I think you'll see how the two actually connect. This is a drawing program. So you can see you've got a canvas here and some drawing tools down the side. There's a pen and the text and a bucket and all the usual suspects for drawing tools. But there's this one here, which is this black button here, which is like a pencil with some little sparkles around it. This is the AutoDraw tool. And what this one lets you do is if I start to draw something, and you've already seen I'm not a very good drawer, right? If I try and draw something like, let's say a bicycle, right? So I know a bicycle has a wheel and has a second wheel and it's got some kind of a frame thing around it that, I don't know, something like that. As I start to draw my really bad bicycle here, you'll notice what it's doing along the top here is it's making suggestions. It says, did you mean? And look, it's got 3 bicycles there. If I click on that, it actually replaces my rather awful drawing of a bicycle with a much better drawing. Now, there's different variations there of different kinds of bikes, and I can pick this object up and I can sort of resize that down to move it around, change its color. Oops, if I can grab it, there you go, and so on. And if I draw another object, like what did we try and draw before? We tried to draw an ice cream, so let's draw that ice cream. We'll draw that. It was like that. It was like that. And sure enough, along here it says, "Oh, did you mean an ice cream?" There you go. There's an ice cream for you. What we're doing here is we're using that vast repository that was created with Quick Draw, where people played the game, in order to build the database of thousands and thousands of examples of what objects might look like and determine their common stuff, so that machine learning can start to recognize the thingness of an object. And now in this tool, you see what it's letting us do is letting us draw something, and then using that reverse machine learning, then saying, well, it looks like you're drawing this. Did you mean that? And so it's helping us out a lot. That's a great example of what machine learning does from having thousands of examples. Okay, so you've got the idea. We can teach a machine something if we can give it enough examples that it can see the common features between those examples. Then it can start to draw some conclusions. Now, if I showed you this, as a human being, most of you would know that this is a banana. And you'd also recognize that this is a banana. But you've got a bit more discrimination than that. You recognize that if I gave you the choice, you'd probably want to eat this banana rather than this banana. This one's a bit bruised and battered, and I don't know, this one just looks fresher, right? So this is probably the one you'd choose. We can teach a machine not only that this is a banana, but we can teach it to tell the difference between the quality of the banana by giving it enough examples of a good banana and a not so good banana. Let's check out how we do that. So here we are in yet another interesting Google tool called the Teachable Machine, and also a part of the AI experiment series. And you'll see that the Teachable Machine actually has 3 different types of projects you can build here. One is an image project, the other is audio, the other is pose. Let's start with an image project and let's look at something here. So I'll click on image project and you'll see it has different classes. So the first class I'm going to call good banana, and my second class I'm going to call bad banana. And you know what, I'm going to add another class here because you'll see why in a second. I'm just going to call this no banana. Right. Now what I need to do is to train the machine what a good banana, a bad banana, and also what no banana looks like. Okay, so I'm going to click this webcam button and it's going to open the webcam. Hi, and here is my good banana. Now, what I plan to do is hold down this record button and I'll juggle myself to get out of the way here. Hold the record button and I will move this banana around and it'll take probably 100 photos or so of this banana. Ready? Here we go. I'll move myself out of the way. Okay. Oh, there we go. Hold that. Okay, so it's taking photos of the banana. I'm just moving it around just to show all different angles. That's what a good banana looks like. And you can see up here it's taken 145 image samples. Fantastic. Let's close that one. Now let's go and open up the webcam for the bad banana. Again, here it is. Here's the not so good, or the bad banana, right? So I'm going to go do the same thing now. I'm going to go down to here and hold the record button while I show it some examples of what a not so good banana looks like. You can see it's moving around there. So again, I'll take about 140 or so photos of the not so good banana. And then just to make this work really nicely, I'm just going to get out of the way here. I click on webcam, right? And I'm just going to get myself out of the way, completely blank frame with nothing in it, and say hold to record, and just let it take a whole bunch of frames of the background, right? It's beautiful background here. Now, so I have 3 sets of samples, one of a good banana, one of a bad banana, and one of no banana. Now I click this button that says train the model. And what it's doing now is it's taking all of those hundreds of photographs and it's building a database to recognize what a good banana, a bad banana, and no banana look like. And it's doing it through lots and lots of examples, just like we've seen in our previous examples that I've showed you. Okay, so we've trained the model. You see now, it's not quite sure what's going on here. Like it's bouncing back and forth there, the little graphs underneath, because I'm in the frame. If I move out of the frame, sorry, that's no banana, right? There's nothing in there. If I put something in there, and now it's not sure what that is, so it's hedging all its bets. But if I take the good banana and put it in frame, yep, definitely a good banana. If I take this one, yep, definitely a bad banana. Take it out, definitely no banana. And so you can see if I put both in there, it's kind of a bit confused now. I'm not quite sure what to make of that. It's seeing bits and pieces of each one, but definitely knows that's good, definitely knows that's bad. Oops, if I put it in frame, because we've trained it to know what the qualities of a good banana and a bad banana are. That is machine learning, my friends. Now, by the way, if you wanted to, you can click this button up here that says export model, and it will actually take you in here. You can actually upload this model, use it in different ways. You can import it into TensorFlow, which is Google's artificial intelligence engine that lets you design all these kinds of things. And here's the code down the bottom here. Here's the JavaScript code that's describing the model we just built. So you can see what we're doing is directly translating this example of the 2 bananas into code, just in case you wanted to know that. So here's an example of how this is working in the real world. What you're seeing here is what the camera on a Tesla sees. So it's a self-driving car, and you can see it's actually recognizing and identifying people as they're walking across the road. If you look here in a minute, there's a guy that jogs across the road. He's coming, there he goes, this guy jogging across the street here, and it's recognized him as a jogger. So it's able to pick out objects, identify what they are. And if a self-driving car, can't identify a stop sign from a tree, from a person, from another building, from another car, then it's not going to do a very good job of driving. So this image recognition and this ability to identify objects from having seen lots and lots of examples of those objects, it's what makes this intelligent car seem so intelligent. But really, it's just a whole lot of really rapid pattern recognition.
So there you have it. I hope you've got a better understanding now of what machine learning and artificial intelligence is really all about. And this idea of pattern recognition, of being able to identify things, we talked about images because that's an obvious one to talk about, but think about all the other applications. You go to Google Photos, for example, and you take a photo and it can identify who's in that photo and it can group them together. That's machine learning. Think about when you are looking on a map and it tells you your commute time, how long it's expected to take you to get to work that morning, because it's looking at traffic, but it's also looking at how long it normally takes when traffic is like that. It's doing some pattern recognition on that to plan commute times. Or your spam filters in your email, for example, when you get a message, how does it know that's a spam message? Because it's looking at lots and lots of other examples where it's already been identified as spam. Now it sees yours and it goes, that looks the same, so that must be spam. That's another example. Or when you go on holidays and you get, maybe you're spending money in a way that you wouldn't normally spend money in a different location or buying different things, and your bank contacts you and says, I just want to check to make sure your credit card's not being misused. The fraud protection, that's all done with machine learning. And things like shopping suggestions, when you're on Amazon or a shopping site somewhere and it suggests people who bought this also bought this other thing that you might like, and it makes a suggestion for you. It's all machine learning. So I hope that this has been interesting for you. I hope you've learned some things, not only about what machine learning is and what it does, but a little bit about how it works as well. It's not quite as mysterious as it might seem. It's just a computer making lots and lots of looking at lots and lots of examples and drawing some conclusions from those examples. It really is as simple as that. Hope you've enjoyed it.